When we were studying linear functions, we were looking at situations that exhibited repeated addition or repeated subtraction. So a constant rate of change, adding 5, adding 5, adding 5, subtracting 3, subtracting 3, subtracting 3. And this repeated addition or subtraction was expressed using multiplication in our function rule. For exponential functions, we are looking at situations that exhibit repeated multiplication, and repeated multiplication is expressed with a power. Let's look at an example. You have 3 guppies, so you start with 3 guppies. We're just going to write 3 here. Each month, the guppy population quadruples. That means after 1 month, a quadrupling happens. You have 3 times 4, which is 12 guppies. You still have those 12 guppies, but your population once again quadruples. So now we have 3 times 4 times 4. Here's what we mean by simplified. 3 times 4 squared. So you have 48 guppies. You still have your 48 guppies, 3 times 4 times 4, but in the 3rd month, quadruples again. So now you have 3 times 4 to the 3rd power of guppies. That is going to be 192 guppies. After the 4th month, 3 times 4 times 4 times 4, and again we quadruple, so we have 3 times 4 to the 4th power of guppies. That is 768 guppies. So we are repeatedly multiplying by 4. That repeated multiplication by 4 is expressed as a power. The function rule can be written 2 ways. We can write 3 because we start with 3, and then we multiply that 3 by 4 repeatedly, in fact, x times. Or instead of using a dot, this is more common, we can use the parentheses to indicate multiplication, and just write 3 parentheses 4 to the x. Again, this represents that we start with 3 and then times 4, times 4, times 4, times 4, x times. Now we can just use our table to find f of 2. When x equals 2, the output is 48. So f of 2 is 48, meaning after 2 months, you have 48 guppies. You could also find this algebraically. So you could use your rule, 3 times 4 to the x, and evaluate that rule, find f of 2, evaluate that rule for x equals 2. 4 squared is 16, 16 times 3 is 48. So this you are able to do if I ask you to find f of a particular x value, you can do that algebraically. For this type of question here, I can answer this one using my table. I'm asked, for what x do we have an output of 768 guppies? The answer to that is 4. After 4 months, you have 768 guppies. That is answering the question posed by this equation. 3 times 4 to the x is 768. This exponential equation is not one that you will learn to solve in this class. So when you're asked to find an answer to a question like, what is x when f of x equals 768, you'll need to use the table in your calculator to answer it, or you can guess and check by doing 3 times 4 times 4 times 4 times 4. Let's look at some more examples. 5 rats, start value of 5. Rat population triples every year. So times 3 times 3 times 3. When will there be 405 rats? That is asking the question posed by this equation. 5 times 3 to what power equals 405? Again, you cannot solve that algebraically, but you can make a table in your calculator for this function rule and look for an output of 405. Or I'm just going to use my cell phone calculator and press 5 equals, press times 3 equals. That gives me how many rats after 1 year, which is 15. Now just press equals again, 45. That is how many rats after 2 years. Press equals again, which multiplies by 3. 135 rats, that's how many rats we have after 3 years. Press equals again, that's multiplying by 3 for me. And that told me I had to press that 4 times. So when x equals 4, I have an output of 405. So 5 times 3 to the 4th power is 405. 3 to the 4th power is 81. 81 times 5 is 405. Ladybugs. There are 12 ladybugs. The ladybug population doubles every year. So we start with 12, and then we repeatedly multiply that by 2 to represent the doubling. This is one we can do if we have a scientific calculator. 2 to the 7th times 12. I just have my phone, and it's not even, can't even do 2 to the 7th, so I'm going to do 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, 64, times 2, which is 128. So that's going to be 12 times 128, which is 1,536. After 7 years, you will have 1,536 guppies. Last example. 4 snakes. The snake population increases by a factor of 5. So that factor of 5, we don't have a word for anything bigger than times 4. So times 2 is doubling. There's that. Double times 2, triple times 3, quadruple times 4. If it's anything bigger, we will say increases by a factor of. So we have 4 snakes, factor of 5. That indicates repeated multiplication by 5. We are asked, when does 4 times 5 to the x equal 312,500? I'm going to count on my calculator. So I start with 4, I multiply it by 5. So after 1 year, we have 20. After 2 years, we have 100. 3 years, 500. 4 years, 2,500. 5, 6, 7. It looks like 7 years. I'm going to check that. So what I'm hoping is 4 times 5 to the 7th equals 312,500. Again, if I had a graphing calculator, I would just plug this function rule into y equals, and then I would look for the x value that gave me an output of 312,500. So 5 times 5 times 5 times 5 times 5 times 5 times 5 is 78,125. Times 4 is, yes, I have an output of 312,500. Finding f of 3, much more pleasant. F of 3 is 4 times 5 to the 3rd power. 4 times 125. That is just 500. So after 3 years, you have 500 snakes.